this and see if, now that's a marker.
Does it erase? Right.
Yes. It's kind of ironic that the ones that are running out also erase poorly.
Yeah.
So it's frustration all the way around. Okay, volume of solid under a surface and above a region in the plane. Okay, so you need to get a handle on the region. So bounded by the line, x equals y plus 2. So in this case, we're going to have orientation's off a little bit, but okay. That's going to be something like that. Okay, actually, I'm going to plot a couple more points just so the line is looking more like it should. Okay. And then x equals y squared. All right, so it's going to be a parabola. So it's this region that serves as the base of a solid, and if it is a surface up above, which I'm only going to graph like approximately. So this marks the top of your solid, z is equal to 2x plus y squared. All right. So this is all about finding the proper limits. So the base of the solid is in the plane z equals 0. Top of the solid is indicated by this surface. And since you're computing volume, your integrand is just going to be 1. So what remains here is to find the proper limits in terms of x, y, and z. Now, so this is how you get your limits in z. And you can see the upper limit in z depends on both x and y. So your outermost limits have to be constant. These limits can depend on at most one variable. These can depend on as many as 2. So since z already depends on 2 variables, your z limits should be, so your integral with respect to z should be innermost. Aside from that, to see what to do in x and y, to get those limits, you really should take a closer look at this region. So if we draw that just in the xy plane, so we have x equal y squared, and x is equal to y plus 2. And this is your region that you care about. So what you need to do is figure out which is more convenient. Is it more convenient to take limits in y or x? So whichever choice you make, for instance, if you choose your outermost limits to be in y, So y is going to go from here to here, and then you got to figure out functions of x, sorry, x being functions of y, to see what the limits for x should be. Or you can go the other way around, figure out your limits in terms of x, from here to here, and define y being a function of x to get you a limit. So whichever way works best. Because some choices may cause you to have to break up the integral, and other choices you don't. So that's something to think about as far as which one is more convenient. So that's as far as I should go with this one. And this is seen in some examples in class, that when you have curves like this that define them as your base of your solid, then you got to figure out the intersections. So the intersections will help you determine the limits, regardless of whether you decide to make x or y your outermost. Yes?
Your line's going the wrong way.
You've got it negatively sloped and it should be positively sloped.
Yeah, I feel like something was off about this one. Yeah.
Cut.
Yeah, I reversed my y-axis when I turned my head. Okay. Okay.
I don't think it would make much difference, but for the sake of non-confusion.
I remember reading in my own calculus book that this whole idea of
That gives her a point, right?
inverse functions, when you have to reverse a sets of x and y, that you could, if you have it graphed on a sheet of paper, you could just flip the paper around and see the graph, and that technique is difficult with books and impossible with blackboards. And now we see why.
She gets a point, right?
What?
You just change your axis and just throw your y on remember those stuff.
Oh, that's what I could have done, I guess. But then it would have been inconsistent with that. So,
You just be turning it around.
yeah.
I guess that's a physics thing.
All right. Are we good then?
Do I get a point?
What?
Do I get a point?
Okay. Okay. So now we're good. Okay. So, alright, so this with the revised picture, the extent in terms of y would be that.